Hi friends, this is Mira again. Welcome to my channel. Today we will discuss step-by-step process to find resultant force of several forces acting on a body by two analytical methods, law of parallelogram and method of projections. Let's have a look at the first example. Suppose number of precast panels are laid together to form a compound wall. To prevent the panel from falling, they are pulled by brackets with the help of ropes. And we want to find out the resultant force acting on one of the brackets. Consider that the brackets are tethered to the ground and the weight of bracket is very small. So let's first of all draw the free body diagram of bracket. There are two supports, one is ground to which the bracket is bolted and another one is rope. First of all, we will consider only ground and ignore the rope. Ground restricts the movement of bracket in vertically downward direction, so reaction will develop in opposite direction and of equal amount as weight of bracket. But as bracket is considered a weightless object, self-weight is negligible and so reaction from ground is also equals to 0. Now let's consider forces acting from ropes and ignore the ground. Bracket is pulling the wall to its position. So we can say that wall also apply pull on bracket as per Newton's third law of motion. As right now we are ignoring the ground, bracket is free to move, but any outside movement is restricted by rope. So reaction will be developed in opposite direction on rope itself. Or let's think it like this. Rope can only pull the wall to position. It cannot push, right? If this is the pull developed in rope, reaction will be in opposite direction. Always remember this concept whenever a rope, a cable or a string is supporting an object. Similarly, this is the reaction developed in another rope. The line of action of both the forces are meeting at this point. And this is the free body diagram of bracket. Let's say magnitude of both forces are given. F1 is 500 Newton and F2 is 400 Newton. Angle the forces make with x-axis are 60 degree and 30 degree respectively. The resultant force acting on the bracket and angle it makes with x-axis is to find out. So let's begin. There are four methods to solve numerical on resultant force. Law of parallelogram, law of triangle, law of polygon and method of resolution. If graphical methods are not considered, analytical method of law of parallelogram and method of resolution is left. Method of resolution can be used for any kind of problem on resultant of forces. But law of parallelogram is applicable if there are only two forces acting on the body. In given problem, only two forces are acting, so we will solve numerical using both methods and compare results. Let's start with law of parallelogram. If given two forces are two adjacent sides of a parallelogram, the equation to find resultant R is under root f1 square plus f2 square plus 2 f1 f2 cos phi. Here phi is the angle between f1 and f2. The derivation of this equation is explained in detail in previous video. Here f1 is 500 Newton, f2 is 400 Newton and angle phi is 60 degree minus 30 degree equals to 30 degree. Put all values in equation and we get magnitude of resultant force equals to 869.72 Newton. Now the equation to find angle alpha is tan inverse f1 sin phi upon F2 plus F1 cos phi. Put all values. So angle alpha is 16.7 degree. But alpha is the angle between resultant and force F2. So to find out angle between resultant and x-axis, this angle should be added, which is already given in problem statement and is equals to 30 degree. So angle theta is equals to 16.7 plus 30 equals to 46.7 degree. Now let's solve same problem with another method, that is method of projection or resolution. In this method, we will find out components of each force along x-axis and along y-axis. Force F1 makes 60 degree angle to x-axis, so x component will be F1 cos 60. F1 is 500 Newton, so x component Fx1 is equals to 250 Newton. And y component Fy1 will be F1 sin 60, that is 433.01 Newton. Similarly, for force F2, angle with x-axis is 30 degree. So x component is F2 cos 30. F2 is 400 Newton. So Fx2 is equals to 346.41 Newton. And y component Fy2 is F2 sin 30, that is 200 Newton. We will keep only required details for convenience. Now Fx1 and Fx2 are two collinear forces and are in same direction, so they can be added together to find resultant force Rx. So Rx is equals to 596.41 Newton. And similarly, y components Fy1 and Fy2 are added to find resultant in y direction, that is 633.01 Newton. So here we get two perpendicular forces acting on the bracket, which can be considered as sides of parallelogram. So the resultant force R of these two forces Rx and Ry is under root Rx square plus Ry square. Put values and we get R equals to 869.72 Newton. And angle between resultant R and x-axis is tan inverse Ry upon Rx. So angle theta is 46.7 degrees. You can observe that magnitude and angle of resultant force we measured by both methods are exactly same. Let's see one more problem. Suppose scaffolding is provided adjacent to a building to facilitate construction work. A scaffold must be strong enough to withstand various loads acting on it, like self-weight, weight of workers and equipments, wind load, etc. Here we want to find out the resultant force of several forces acting at one of the joint. As there is no direct external support to the joint, only the forces acting on the connecting members will be included in free body diagram. So this is the free body diagram with all the forces along x and y axis. Rearrange the forces so that all of them meet at the center. Now let's have a look at the given data. F1 is 1.5 kN, which is acting along x-axis. F2 and F3 are 3 kN and 4.5 kN respectively, which makes 30 degree angle to negative x-axis as shown here. And F4 is 6 kN acting in downward direction along y-axis. As we already discussed, there are two analytical methods to find resultant force acting on a body, out of which law of parallelogram can be used if only two forces are acting on the body. As number of forces are more than 2 in our case, we will solve the numerical using method of projections only. So first step in this method is to resolve each force into two components, one along x-axis and another one along y-axis. F1 is equals to 1.5 kilonewton and it makes 0 degree angle to x-axis. So x component Fx1 will be 1.5 kilonewton and y component Fy1 will be 0. Second force F2 is 3 kilonewton and it makes 30 degree angle with x-axis. So x component Fx2 is 2.6 kilonewton and y component Fy2 is 1.5 kilonewton. Force F3 is equals to 4.5 kilonewton and it acts as 30 degree angle to horizontal. So Fx3 will be 3.9 kilonewton and Fy3 will be 2.25 kilonewton. Similarly, F4 6 kilonewton magnitude force makes 90 degree to x-axis. So Fx4 is equals to 0 and Fy4 is equals to 6 kilonewton. As all the horizontal forces acting along x-axis are in same line, the next step is to find resultant force Rx by adding all horizontal components. Here Fx2 and Fx3 are collinear to Fx1 but in opposite direction, so they will be subtracted. So Rx is minus 5 kilonewton. Negative sign shows that Rx acts along negative x-axis. Similarly, all vertical forces are to be added to find resultant force Ry. In our case, Fy3 and Fy4 are in opposite direction to Fy2. So, resultant force along y-axis Ry is minus 6.75 kilonewton. And here we get two perpendicular forces acting on the joint which can be considered as sides of parallelogram. The resultant force R of these two forces Rx and Ry is under root Rx square plus Ry square. Put values and we get R equals to 8.4 kilonewton. And angle between resultant R and x-axis is tan inverse Ry upon Rx. So angle theta is 53.47 degrees.